Okay, so this video is about how to deal with parallel circuits. So again, it's kind of like the series one, is that can I replace these two and actually get the same amount of total current just in one resistor? Okay, so can I get the same amount of total current in just this one here? Okay, so it's basically condensing this parallel into just this here. So the formula for that, so is this a little bit harder to prove? So we're going to call this current here. I want the exact same current here. It's a bit harder to prove. I'm not going to do that. I'm literally just going to give you the formula. So I'm going to say that the answer is 1 over the total resistance is 1 over R1 plus 1 over R2. And each goes for each branch. This is the resistor on one branch. This is the total resistance on another branch. And by that I mean, if I had, for example, a question like this. So this is, imagine 10 ohms here and 20 ohms there, like that. My 1 over my total resistance is going to be 1 over 10 plus 1 over 20. So I'm going to put that in here. So 1 over 10 plus 1 over 20. So that's my 1 over my total resistance is 3 over 20. Okay, and then what I need to do to have my total resistance, I need to flip it over. So it's going to be 20 divided by 3, which is 6.67. So what would happen here is if I replaced this with just a resistor of 6.67, it would have the same amount of current before the current splits off. So what's actually happening here is the current, I've got a current of, I don't know here, and what happens is it splits off and then comes back. But what I want is a circuit where I get the same amount of total current going through it there. So you guys have a bit of a go here. So I'm going to do an easier one and a hard one. So I'm going to leave that up the top. Okay, so let's have a simple one to start with. So I've got, this is 30 and this is 70. So what is my total resistance there? And then this one, I'm going to make this a little harder. Okay, this is 20 and I don't know this resistance. Okay, but I do know that the total resistance is, trying to think of 5 ohms. Okay, so I do know that the total resistance of this is 5 ohms. So pause the video and have a go. Okay, so this one, I'm going to use the formula. 1 over RT is 1 over 30 plus 1 over 70. So I'm going to put that into my calculator. And you can use the fraction button up here. So you've got 130 plus 1 over 70. That's 1 over 21. So 1 over RT is 1 divided by 21. So my total resistance, I'm going to flip the 21 and 1 upside down. So it's going to be 21 ohms. All right, this one's a little harder, okay, but I've got 1 over 5 equals 1 over 20 plus 1 over something, okay. So what I need to do is just a bit right. So I'm actually going to put that. So I've got 1 divided by 5, 1 over 5 there. And of course, this is addition, so I've got to take this away. So minus bracket 1 over 20, close bracket. And I'm left with this question mark. So 1 over question mark is 3 over 20. So what I need to do, much like final total, I need to flip this upside down. So 1 divided by that, 20 over 3. So again, this is going to be 6.67 ohms. Okay. So these ones are a bit difficult, but in my next video, I'm going to do what happens if you have a mixture, so a little bit of series and a little bit of parallel.